Good morning everyone. Myself Amla Mary George. In this new academic year, I will be teaching Complementary Mathematics Module 1 and 2. During this difficult time, it is with great pleasure that I am sitting in front of you, and it is very interesting for me to learn new platforms and softwares, and I hope it is interesting for you guys too. Surely I believe that this is a great step towards the future of learning. So let us begin this session. First, in this presentation, we will discuss section 9.1, vector functions. So before beginning the definition of vector functions, we will try to understand the meaning of the words vector and functions. And I am sure that all of you must be familiar with these two words. Still, let us just brush up what we know. So, what is a vector? A vector is basically an object which has both magnitude and direction. And geometrically, we can represent a vector using a directed line segment. And the magnitude of this vector will be the length of that particular line segment. So, a vector is an object which has two components, that is the direction and its magnitude, and it is represented by v equal to x comma y. Now, what is a function? A function is a relation from a set of inputs to a set of outputs. And one thing that we must keep in mind is that for each input, we will obtain exactly one output. Each input must be related to exactly one output. Now, if we consider an example, say f of x is equal to x plus 2. That is, f of x is equal to x plus 2. If we consider this function, if x is equal to 1, what will be the value of the function? F of 1 will be equal to 1 plus 2, which is equal to 3. So, for the function, for the value x equal to 1, the function value is 3. Now, we can also note that there will be no other value of x for which the function value would be f of x is equal to 3. Now, next we will discuss about the parametric curves. Now, we all know what a curve is. What is a curve? A curve is a set of ordered pair x comma y. Now, when do we call such curves to be parametric? A curve is said to be parametric if the coordinates, that is x and y, they are represented by continuous functions. So, we are all familiar with many curves like function f of x equal to x or sin x or cos x. All these curves are represented by ordered pairs, and these curves are said to be parametric if these ordered pair x and y can be represented by functions, continuous functions, that is x is equal to some function f of t and y is equal to some other function g of t. The point that must be noted is that these functions must be continuous in some closed interval. Now, as we have defined the ordered pair x comma y, we can also extend it to 3 space as well, and curves, parametric curves in 3 space are called space curves. So let us come to the beginning of our section, that is vector functions. So what is a vector function? Vector functions are those functions of one or more variables whose range is a set of vectors. Now, they are represented by r of t is equal to f of t comma g of t or f of t I plus g of t j. Now, similarly, we can consider having a vector function with 3 coordinates, that is r of t is equal to f of t comma g of t comma h of t or f of t I plus g of t j plus h of t k. Now, in this presentation, we are discussing two types of problems. The first one will be to graph a curve traced by a vector function, and the second one is to find a vector function which describes the curve of intersection between two surfaces. So let us consider, or let us discuss the first type of problem, that is to graph a curve traced by a vector function. Now, problem, what we must do is we must consider the parametric equation of the given curve and then eliminate the parameter t from it. So the problem is simple. We can use an example, and I hope all of you have the text with you guys. The example 1. Now what is example 1? Example 1 is that we have to graph the curve traced by the vector function r of t is equal to r of t is equal to 2 cos t I plus 2 sin t j plus t k. So to solve this problem, what we must do is we must find the parametric equation of the given curve. The parametric equation will be x is equal to 2 cos t, y equal to 2 sin t, and z is equal to t. So we have found the parametric equations. Now the next step would be to solve the equations and solve the equations for the parameter t. How can we eliminate t from these three equations? Now we are all familiar with the equations, trigonometric equations, that is cos square t plus sin square t is equal to 1. So we have x is equal to 2 cos t and y is equal to 2 sin t. Now x square plus y square, what will be x square plus y square? 2 square cos square t plus 2 square sin square t. Now taking 2 square common, we get cos square t plus sin square t. Now we know cos square t plus sin square t is equal to 1, so the value would be 4. So we get x square plus y square equal to 4, and we also have z is equal to t. Now x square plus y square is equal to 4 is the equation of a circular cylinder. Sorry. X square plus y square is equal to 4. We are all familiar with this equation. So x square plus y square will be a circular cylinder whose radius would be 2. Now when we combine these two equations, that is x square plus y square equal to 4 and z is equal to t, we will get a set of circular cylinders along different values of z. So it will basically form a circular helix. The picture is clearly given in the textbook, and now the example 2 can also be done in a similar manner. That is, we just have to we have to find the parametric equation, and then we must eliminate the parameter t from it. Now next type of problem is to find the vector function describing the curve of intersection between the surfaces. Now how can we solve such problems? To solve such problem, we must parameterize the given curve of intersection. We must parameterize the curve of intersection by x equal to t. That is, first we need to find the vector function which describes the given curve. So for that we will parameterize the curve of intersection by x equal to t and then substitute it in the given surface to obtain the required function. So this problem will be clearer if we do an example. Now if we see the example 3 in your textbook, we must parameterize, or we must find the vector function which describes the curve C of intersection of the plane y equal to 2x and the paraboloid z is equal to 9 minus x square minus y square. So we are given two surfaces. Now these surfaces are intersected by a particular curve. We need to find the vector function of that curve. What we must do is, first we must consider the parameter x is equal to t. Say x equal to t is the parametric equation of the required curve. Now when x is equal to t, what will be the value of y? Y will be equal to 2t. Now using these two equations, we have z is equal to 9 minus t square minus 2t whole square, which is equal to 9 minus t square minus 4t square, that is 9 minus 5t square. So we have, when x is equal to t, we obtain y equal to 2t and z is equal to 9 minus 5t square. Now, so we have obtained x equal to t, y equal to 2t and z is equal to 9 minus 5t square. Using these three parametric equations, we can form the vector function. That is, the vector function would be given by r of t is equal to t I plus 2t j plus 9 minus 5t square k. So what did we do to solve this problem? We first consider the parametric equation of the curve to be x equal to t, and we substituted the value of x equal to t in the given surfaces y equal to 2x and z is equal to 9 minus x square minus y square, and found the parametric equations of the curve, that is x equal to t, y equal to 2t and z equal to 9 minus 5t square. And using these parametric equation, we could find the required vector function. So this is how we can solve the problem. Hope you are familiar with these problems. To get a more clear picture, it will be better to do the exercise problems. So I have quoted the exercise problems which you guys must do referring the examples 1, 2 and 3. Try to solve the problems 1 to 5 and 11 to 14. That's it for today's session. Thank you. Stay home, stay safe.